This video goes through section 8.1, law of sines. So on this slide here, you can see both sort of versions of the law of sines. Now, usually when we actually use the law of sines, we're just going to use two of these fractions set equal to each other. So we could say law of sine of A over A equals sine of B over B, or we could say sine of B over B equals sine of C over C, or we could say sine of A over A is equal to sine of C over C. So any two of those fractions will be equal. So the sine of an angle in a triangle divided by its opposite side will always be equal to the sine of another angle divided by its opposite side in the triangle. And then, this is a fraction, right? Fraction equal to a fraction. The reciprocals would also be equal. And so if we're looking to solve for an angle, say angle A, then we would use this form here, where the sine of A or B or C is on top. If we were trying to solve for a particular side, say A or B or C, then we would use the form on the bottom where the unknown is already on top. So it's less algebra that you'd have to do. Okay, before we even get to law of sines, though, let's think about how we're going. Well, let's develop a formula for the area of a triangle. And so we know the area of a triangle is 1/2 base times height. So for this particular triangle, the base I've drawn on the bottom, that's C, and the height, of course, we know the height is always perpendicular to that base. And we've marked that as h. So 1/2 CH, or 1/2 base times height. However, with that height in there, h, it creates a right triangle on the left-hand side. And so we know that the sine of that angle, A, big A, is equal to h opposite over hypotenuse h over b. And I could do a little bit of algebra and solve that. Sine A is equal to h over b. Solve that for h. So multiply both sides by b. And so then we could get the area is equal to 1/2. Instead of having 1/2 base C times height h, I could substitute in what h is equal to. And so this is a formula. And if you think about the relationship between the A, the B, and the C, C and B are two sides of the original triangle, and A is the included angle. So if we know the measure of the included angle and the sort of adjacent sides to that angle, then we can use this formula, 1/2 CB sine A. And so let's use this formula to find the area of a triangle with side B, side C, and angle A. So pause the video and then find that using that formula. Okay, so once we plug all that in, I'm using for the angle, of course, I'm leaving it as degrees. And then we get 236.6 units squared. Now, I'm going to use this formula to develop the law of sines. So instead of solving the area of that triangle based on BC and angle A, we could do it with A and C, and then the included angle would be B. Or we could do sides A and B, and then the included angle is C. So those all have to be equal because they're all different ways of finding the area of the same triangle. And what if I divided all three of those by 1/2 ABC? Most of them cancel. but not everything. And then that just gives us what's left is the law of sines. Okay. All right. So let's use that law of sines. Again, the reciprocals are also equal to each other of all the three of those fractions. We're going to use two of those fractions set equal to each other for any given moment, though. So even though we write all three, we're never going to use all three fractions to solve the triangle. Also, law of sines, and then next lesson is law of cosines. These are rules or formulas that are useful for a non-right triangle. You can apply them for any triangle, really, but we don't use these for right triangles because we have SOHCAHTOA, which is easier and simpler. So we don't try to use law of sines or law of cosines when we get there for any triangles that are right triangles, because we already have something called SOHCAHTOA. We can use it, we can find the things that we want to find so much easier by using SOHCAHTOA if the triangles are right triangle. Here, these triangles are non-right triangles. All right, so here's a triangle. We want to solve each triangle. So we give you three things, and you want to find the other three. So in this case, we've given you two angles and a side that's not between them. So we want to think about, like, what's the situation as far as side angles and those kinds of things. All right, so this is angle, side, because we have two angles and the included side. In order to use law of sines, we have to know, you have to have at least one pairing of an angle and an opposite side. So we either have to know angle A and its opposite side, we have to know angle B or its opposite side, or we have to know angle C and its opposite side. We need one pairing in order to use law of sines. And here we have angle A and its opposite side, which is side A. So we know, trying to get rid of this marks up here, we know angle A and we know side opposite A. And so we also know angle B, and so we are going to use this to find side B. Side B, then when I rewrite my proportions, I'm going to use this one here because it has B in sort of the top left corner. I want the unknown that I'm going to solve for upstairs, and I just start with it on the left. All right, so plug in and solve for B. All right, so B over sine 60 equals 20 over sine 40 degrees. All right, so we just do a little bit of arrangement, and we can find that B is equal to 26.9. All right, so we now know B. We could have found angle C first too. We don't know it directly, but we could very quickly find angle C. We know the three angles of a triangle always sum to 180 degrees. So we know that angle C is 80 degrees. All right, now we want to find the side opposite angle C, or side C. So set up the proportion that you would think would be useful there. All right, so again, I'm going to look for C. I always rewrite my proportion so that the unknown is on the top left. That way I can just multiply both sides of the equation by sine of angle C. And then I've got C upstairs and by itself. So multiply both sides by sine of 80. And then just pick up your calculator and plug that in. And so C is equal to 30.6. All right, so the next triangle, number 2. Think about side angle, or angle side, or what's the situation here? All right, so this is angle side angle. In other words, I know we used these shortcuts, angle side angle, to prove congruent triangles back in geometry. Here, we're just using them to identify like what part of the triangles we know. What 3 things are we given? And so in this case, we're given 2 angles and the included side. Now, we don't know an opposite angle and opposite side pairing here. However, we know we can find angle C pretty quickly because the 3 angles, we're given 2 angles, we know the third angle. And that third angle C is opposite to 12. So boom, we have an opposite angle side pairing that we need to be able to use law of sines. All right, and so I'm going to use it to find B first. And so plug in what you know there, and then just do a little bit of algebra. Move the multiply both sides by sine 62, and B is 10.6. All right, and so now do one more time. We want to find A this time, side A. And so this would be a useful proportion, I think. And I tend to go back and use the sort of the original. They gave us side 12. If I end up using, instead of using side C over sine C, instead I use B, and I made a mistake with this calculation, then, then that error is going to propagate through the problem. So I tend to go back to sort of the original things that I know that I was given, mainly C and then angle C. Angle C is not really an estimate. We know it's exactly 94 if the other 2 are exact angles as well. All right, so plug that in and solve for A. All right, and a little bit of algebra, and then your calculator tells us that A is 4.89. So it's kind of important that the last 2 problems we kind of reiterate that the first problem had angle, angle, side. This one had angle, side, angle. And now we want to think about this side, about this triangle. So I'm drawing this triangle for you here. And so we have 2 sides and a non-included angle. All right, so we do have an angle and side pairing, angle A and side A. So that's crucial for knowing law of sines. But we're going to find that in this situation, when we have angle side side, if you remember when you did geometry last year, that angle side side was not a legitimate shortcut for showing 2 triangles congruent. And we'll explain how that's related to what we're doing here. So anyway, let's go through and do the same thing. Pause this video and then calculate the missing pieces. All right, so I'm going to find, I have side B. I need to find angle B first. That's the paramount. You have to find that first. So I wrote the equation with sine B in the top left corner. Not crucial that you do that, but now I just have to multiply through both sides by B, 16, in order to get my sine of B by itself. So you need the sine of B by itself and upstairs, so why not just start with it on the left-hand side? All right, and then that's just kind of calculator work. And then the inverse sine of that ratio gives us angle B of 22.06 degrees. All right, so then once we know B, we can then, we know angle A, we know angle B, we can find angle C. All right, and I'm just rounding that to 130 degrees. I rounded angle B to just 22. Okay. All right, and then finally the last side, C. And again, I'm just going to write the equation so that the unknown C is at the top left corner of the proportion. And then I can multiply both sides by sine, fill it in, and multiply both sides by sine C, or sine of 130 degrees. And then your calculator gives us 32.6. Okay. So remember that this was angle side side. And in this situation, It's what we call the ambiguous case, because sometimes weird things happen. All right. In this case, everything seemed to turn out nice, but let's look at number 4. All right, so very similar situation. I kept the angle the same. Angle A is 28, A is 13, and B is 16. So I changed the side, the third side on the right, and I made it a little bit shorter. So we have something more like this now. So instead of side A, opposite angle A, side A being 20, now it's a little shorter. It's 13. Okay. So let's solve this one again. Very similar to what we just did. Pause the video and solve that. Okay, so this again is angle side side. I'm going to find angle B first. And again, we use the same proportion we did before. Set it up the same way we did before. And this time angle B ends up being 35.3. And then we can, of course, subtract those two from 180 to get angle C. And then with angle C, we now can find side C. All right, so side C, we use this proportion. And then, if we multiply both sides by sine of 116.7 degrees, we would get side C of 24.7 units. Okay, now there's a problem here, though. that side, 13, and this is also, remember, this is an angle side situation, two sides and then non-included angle. That side 13 opposite the 28, there's nothing to say that side is right where it is. It could just as well be over here. Still works. It's still 13. I haven't violated any of the three things that was given. That side is still 13. The angle is still 28. And side B is still 16. So this is called an ambiguous case because in some situations with angle side side, two triangles are possible. So if you think back up to the example 3, a second triangle was not possible because that's the side that is sort of unknown where exactly it is. In that case, it would be that opposite the 28. The 20 is just too long. If we tried swinging it back down around like we did with the 13, then it wouldn't form another triangle. But in this case, 13 was short enough, it was shorter than the 16, and it can form another triangle. So we have really this other little triangle. I left sort of the ghost behind, that shows kind of where the original triangle was and sort of where this new triangle is. Okay, so now we need to solve that. And so if we went through the process, I think you would find that, like, oh, well, this is just the same as it was before. And so we have to think about it a little bit. All right, so I've called the new angles B prime and C prime, just to differentiate them. And also the third side C, I'm calling C prime, to differentiate them among the other sides that we just found in the first version of this triangle. And so if we think about that second possible triangle, the angle B prime here, that angle is supplementary to this angle. And also that side 13 is the same as that side 13 out here, if you remember. So that kind of ghost little triangle out here is isosceles. And so that angle is also the same as the one on the other side because of the isosceles triangle theorem. So that angle is really the original angle B. And so if we take our original angle B down here, the 35.3, and we take the supplement of that. So if that's this angle over here, it's also this angle here, and that B prime is the supplement of B. And so we can just take B and subtract it from 180 to find its supplement. So B prime is 144.7 degrees. Now we can, then look and say, okay, well, I know angle B prime. I know angle A, still 28. I can find angle C prime from those. And it's going to be pretty small. It makes sense that it's going to be pretty small. And then I can use that with the law of sines to find small c prime, the length of the side. Okay. And so using your calculator, then that's 3.5. So when you get the situation of angle side side, you have to potentially look for another triangle. And when you draw these triangles, I would recommend that you draw them exactly the way I've done it here. The known angle on the left, the opposite side to the right of it, and then the other known side sort of between those, just like this is the case. So that way you can feel comfortable that you're drawing it the same every single time. All right, and then now let's look at a fifth case. We have, again, a known angle, two sides. One angle is opposite the given side. This will end up being, again, an angle side-side situation. So if we just go through the set of the same process and we try to find sine of angle B and then do the inverse of it, well, what I did first before I did that is I wrote down here what that ratio, sine time 16 times sine of 28 over 7, and that's equal to 1.073. And you might sort of suspect that that's going to be a problem. Remember, that's a sine ratio, and that can't be bigger than 1. So we get a domain error. And so when you get a domain error, what's going on? It means the triangle looks like this. So I've drawn it to scale. If you drew it, you probably wouldn't be drawing it perfectly to scale. But that side opposite the known angle is just not long enough for it to come down and hit that side C. And so no triangle is possible in this case. And so you get that situation when you have angle side side. So you can see the three possible outcomes when you are trying to solve a triangle and you know angle side side. You have one triangle, or you have the possibility of two triangles in example 4, and then example 5 you have no triangle possible. And you'll see that because your calculator will give you a domain error when you try to do it. All right, so let's look at some more examples. So number 6, you're given the angle, and you're given the side opposite the angle, and then another side as well. So this sounds a lot like law of, angle side side again. But let's see what happens with these. So let's solve this one. So when we do we're going to use law of sines. Sine b over 9 equals sine of 95 over 7. And you can see, again, we get a domain error in this case. So no triangle is possible here. The side, think about this. This is, this angle A is bigger than 90 degrees. It's obtuse. And the side opposite it is smaller than that other side. So it's just not possible. You would not get a triangle in that case. All right, let's look at number 7. So again, we have an angle, an opposite side, and then another side as well. So again, this is still angle side side. So solve that one. So it looks something like this if we were to draw it. And so first thing we're going to do is look for B. And so that is 50.7. All right, and then A, we can just, we know the two known angles, 37 and 50.7. and the third one have to add up to 180. So we can just subtract the two known ones from 180. All right, and so now we want to find side A. All right, and then we'll just use a little bit of algebra and our calculators, of course. And so A is 23.2. So in this situation, is there a second triangle? And the answer should be yes, because this opposite side here, the 14, is smaller than the 18. So this is going to swing back around and possibly give us a second triangle. All right, so it looks kind of something like this. Probably not drawn to scale exactly, but you get the idea. All right, so again, that angle B prime is the supplement of the original angle. Let's draw that again. So remember, this was the original angle B. This is 14, this is 14. So this angle, that's this ghost triangle in here, is isosceles. And so these are both angle B's from the original triangle. And so B prime is its supplement. So we can just say find B prime by subtracting B from 180. And then, of course, we can find A because all three triangles have to sum to 180. And then find A prime by using law of sines. All right, so let's look at a word problem. Now, if you remember, we did word problems, angle of elevation and angle of depression, and we said you cannot use law of sines and law of cosines. Well, now you can. And so let's look at this example. This is a similar example that we saw in previous chapter. Jorge and Mercedes are each on opposite sides of a tower and measure the angle of elevation to the top as 23 degrees and 35 degrees respectively. If they are 420 feet apart from each other, what is the height of the tower? So first we want to draw a picture and label it. Okay, so the vertical line in the middle, this segment there is the tower. And Mercedes has an angle of elevation of 35. Jorge has an angle of elevation of 23. Of course, Jorge is further away because his angle of elevation is smaller. All right, what's the angle up at the top there, that red angle? All right, so all three angles have to sum to 180. So that big angle up there is 122 degrees. Now, use law of sines to find the length MT. And in this case, we have the situation of angle, side, angle. So it's okay. We're not going to have the ambiguous case here. All right, so TM or MT over the sine of 23 equals the 420 over the sine of 122. So with a little algebra and the use of your calculator, you can find that TM is 93.5. So now we have this right triangle. So now we can just use SOHCAHTOA to find the height of this right triangle. All right, so that would be the sine, right? What relationship do those three things have? The 35 degrees, the height, and the 193.5. So they fall into a sine ratio. And a little algebra and your calculator gives us the height of 111 feet. So you can see this is a lot easier. Before we had to do systems of equations and all kinds of stuff, much faster if we're allowed to use law of sines or cosines. All right, so this is your homework. Due next class.